We're doing today. I just wanted to let you know we are starting it's not really a new section. It's kind of taking what we know and blending it together. It's called Piecewise Functions. So as we start to look at this, you're going to see some interesting things. First off, you're going to be given a worksheet. The worksheet is either going to be a Word document or a PDF. Okay, for me, I'm using a PDF today because I like to use that to edit it. It's the easiest thing for me. Open it up in your PDF. You can click over here, Comments, and it's going to load a taskbar across the top for you. And here you go. You have pens, you have highlighters, you have text box, everything you need to be able to edit this document and turn it in focus. Okay, let's get started. So piecewise functions are just this. They want us to describe, consider the following piecewise functions and graph the representations. Well, first off, let's talk about what is a piecewise function. Okay, here's your text box. So a piecewise function is exactly what it says. This here, all this stuff, it looks so confusing. A piecewise function is a bunch of pieces of different functions all put together. So to formalize that, it's one or more functions that are put together. And they have restricted values of x. So what does that mean? So look at this first one. At this point in our academic career in algebra, we should notice that if you take a look at this, look, x squared minus 1. This x squared here should tell you that's a quadratic function. Okay? And you look at this, 3x plus 2. This is a linear function. It looks like y equals mx plus b, where m is your slope and b is your y-intercept. But notice they've added something to it. So this quadratic is only valid when x is less than or equal to 0. And this linear function is only valid when x is greater than 0. Notice these symbols here. These symbols are very important. This symbol here, greater than or equal to, it includes 0. This symbol here, greater than, it excludes 0. That's why when you look at the graph, this dot here is open and that dot there is solid. Is this a function? Yeah, it passes a linear or a vertical line test. We draw a line here. It only crosses once. What about where they kind of meet or they intersect? Well, that does not include it, but that does. So it's still a function. It passes a vertical line test. Okay, let's start to look what they're asking us for. Label the pieces of the f of x on the graph above. All right, so we just did that. Okay, we said that this first part here, the x squared minus 1, this is the quadratic function. We said this linear piece here, that piece there is the linear function. Great. What does the closed dots or closed circles mean? Look, we click the text bar. We can create our box. And we can say the closed dot includes the value or the number. And then, so what does the open dot mean? Oh, well, the open dot and I know your English teacher will hate me because I'm not using complete sentences, but I only want to make sure you know what you're doing. Give the domain for which the graph is linear. Well, take a look. The domain of what, first off, they gave it to us right here. This right here tells us what the domain is. Okay? The domain for the linear, because this is the linear function, is x is greater than 0. Look right here. Is it? Yeah, 0, 1, 2, 3, 4, and the line goes on forever, so it doesn't include 0, but everything greater than 0. Then it says, well, what's nonlinear? Well, that's just the opposite. That's given to us right here. X is less than or equal to 0 because it includes, it's a solid dot right there, and it goes this way forever. Let's look what they ask us on the next one. Students at a local high school in New York City were reviewing piecewise functions as part of the New York State Common Core math curriculum tutoring program, blah, blah, blah. We don't need any of that information. What we do need is they came across this graph. Here's your graph. Notice there are 1, 2, 3, 4, 5, 6 pieces. These are horizontal lines. So these are always the equation y equals whatever number they cross the y-axis at. And this one is what, 46? Here's an equation, y equals 50. Y equals, 48. This one's y equals 50. This one is y equals 52, 54, 56. There's 6 of them total. Oh my gosh, look at that. What do they ask as the first thing? How many pieces are in the step function? 6. Then it says how many intervals make up this step function. What are the intervals? Okay, so if there are 6 different functions, each one has its own interval. So there are 6 intervals. What are the intervals? 0 to 1. Then you have 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Be careful when you write something like this out. You have to write 0 is less than x, which is less than or equal to 1. There's one interval. The next interval is 1 is less than x, which is less than or equal to 2. Dot, dot, dot. And you keep going. Why do we use open circles in some situations and closed circles in the other? Well, we just talked about that above. Sometimes we have to use these if the number is included or if the number is excluded. If you look at this, because of the way they have it set up, where this one is not included, but that one is, this one's not included, but that one is, if you draw a vertical line through any of this, I know these are horrible vertical lines, it only touches this line once. So while they may not be continuous, it's still a function. Are the piecewise functions linear or nonlinear? Let's take a look. So this particular function is what? Linear. This particular function is linear. This particular function is linear. That particular function is linear. Each individual piece is linear. As a whole, is it all linear? No, because each one is slightly different. They all have the same slope. Okay, this has a slope of 0, that 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 has a slope of 0. So yeah, I mean, it is linear. And then we say, what is the range of this piecewise function? Okay, so again, range is determined by your y values. Domain is x, range is y. So the range of this function, well, the y values that are used go from where? 46 up to 56. So you could say the range is 46 because it includes 46, it includes 56, and it's everything. It's the ones that are in between. Here's the next question. So Fluffy's dreaming of indoor, blah, 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 all this stuff. When they give you all this wording, guys, I'm telling you, this entire chunk is just distractor. Feel free to read it on your own. Okay, the important meat and potatoes of it says the following piecewise function represents their prices. Here's your functions. Notice these. F of x equals, so this is f of x equals 12. F of x equals 19, f of x equals 25. It looks a lot like the problem above. This is some sort of a step function. because it's horizontal lines at 12, at 19, and at 25, but they've restricted the domains. Remember, these are domains here. So all of this here is giving you your domain. So if you're looking at this, we have to be careful. It says graph it. Okay, so the first one is going to be at 12. So I'm assuming that this is going to go by 5, 10, 15, 20, 25. Great. And down here you're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You gotta watch this because look, this says it's supposed to go up to 14. So we might have to have a couple out here or so, whatever. We'll figure that one out. The first one is 12. So we find 12, y equals 12. So on the y-axis, it's about right here. And where does it start at? It says 0 is less than. So 0 is less than x, which is less than or equal to 2. Okay, so at 12, you have to put a open dot at where 12 is, a solid dot at 2, and we connect our lines. Great. 19 is the next one. And it goes from 2 to 6, both open dots. So where's 19? All right, so right here about is 19. And it goes to 6. 5 is here, 6. And you connect your dots. Ooh, man, we're just graphing the individual pieces only for the x's they tell us we can use. Imagine that. Here, x is going to be at 6, and it's going to be solid. 14 is going to be solid, but what number are we at? 25. So solid dot at 6, solid dot at 14, which ends up being about right here, and then we connect our lines. Great. We put that one on a graph. Here we go. It says choose the correct expression to represent the piecewise function. So here, this f of x is, they give you 3 different functions it could possibly be. F of x is 3 different functions it could possibly be. F of x is 3 different functions. Notice, horizontal line, a linear line with an actual slope that's not 0, and then here's another horizontal line. So where is this, at what value of y is this horizontal line at? Well, this is the line y equals -3, because if it were to intercept, it would be at -3. Great. Let's do the other one while we're on the same brainwave here. Here's also a horizontal line. This one would cross at 5. So this is the line y equals 5. All right, the 2 easy ones are done. There's that one. There's that one. This here's the hard one. So we have to pick a point. Pick any point you want. We start right here. Rise over run is how we figure this out. We need to know what is the slope, what is the y-intercept. Well, I can tell you the y-intercept is right here. So that's -3. What's the slope? It went up 1, 2, and over 1. So 2 over 1, 2 divided by 1 is 2. So 2x minus 3. That's our equation. Oh, imagine that. It's right here. So from -3, see the x value, -3, not inclusive. This tells us it's not inclusive. All the way to 2, which is inclusive because less than or equal to tells you to include it. There's our line with a slope of 2, y-intercept of -3. We just picked that out. More piecewise functions. So in this particular one, they're giving you, this is your domains. Here is your given domains here, okay? Domains. There's all of your possible domains. All the domains you could possibly have that they gave us in anyway. And they want to know, well, if these are the given domains, where do they go to for range? And this is a list of all of your range. The possible range for the given domains. The hard part of this is we have to say we have these restricted domains here. So where where do we plug the number? Which one of the three functions do we plug the number into? Let's look at this one here, -7. So is -7 in which one of the following ranges? Well, this says x equals, I'm going to go ahead and erase this so we can see this better. Or maybe it just won't work. Anyways, it says x is less than or equal to -3. So is this -7 falls in this range? Okay, so we have to take this and plug it into the first equation. So -2 times a -7 is a +14 plus 1. That gives us 15. So this one goes down to this one. Great. -3. Well, -3, is this included? Because I see -3 twice. Does this include -3? No, it doesn't. This one does. So we have to plug -3 into the first function again. -3 times -2 is 6. 6 plus 1 equals 7. So -3 here, this one goes to 7. Notice we're making a mapping diagram. 1. So 1 doesn't fall in this. 1 is greater than -3, but it's less than 5. So we had 2 of them that fell in here. 1 is falling into this one. So 1 times 3 is 3. Minus 1 equals 2. So 1 goes to 2. Now we have to look at 5. Is 5 included here or here? Again, this symbol here is what's telling you it's included. So it's in the first one. Well, 5 times 3 is 15. 15 minus 1 equals 14. So 5 goes to 14. And it leaves us 2, but we have to double check. Is it really 13? I don't know. 8. Is 8 greater than 5? Yes, it is. So yes, 8 falls into this one. So 8 plus 5 is 13. So 8 goes to 13. And you're pretty much done. Okay, this is what piecewise functions are, guys. It has, while it may look a little strange because we haven't really seen things like this before, it's a bunch of individual functions, and each function has its domain or its x values restricted. So figure out what x are you plugging in, and you go from there. Be mindful, remember, less than, greater than is not inclusive. It's an open dot. Greater than or equal to, less than or equal to is inclusive. It includes that number. And that's all we had for this lesson. Your worksheet is 2 problems. I hope you guys have fun with it. Have a wonderful day.